Welcome to All Wired Up, where you dive into exciting topics around tech, innovation, AI, and the future of digital life. Strap in, subscribe, and enjoy the journey.
Welcome to All Wired Up. Today we're diving into how to build a payment system, Stripe versus PayPal API. Have you ever wondered what actually happens behind the scenes when you click, purchase, online? It's more than just sending money. It's a carefully orchestrated dance of systems to ensure your transaction is secure, accurate, and reliable every single time. Our core question today is, how do online businesses ensure consistency, security, and fault tolerance in their payment processes? How does the money truly flow safely from customer to company? At its heart, online payment processing involves many moving parts. A customer makes a purchase, their bank processes the payment, the merchant's bank receives it, and the merchant's system needs to know it all happened successfully to fulfill the order. This seems simple, but what if the internet connection drops? What if a message gets lost or sent twice? Building this from scratch is incredibly complex and risky, which is why services like Stripe and PayPal exist. Stripe and PayPal are financial infrastructure powerhouses. They act as your trusted intermediary, handling the intricate, sensitive details of payment processing. By using their APIs, businesses don't need to directly touch confidential payment information, which is a massive win for security and compliance, specifically PCI compliance. They're built to accept payments and help businesses scale faster, giving them the tools to manage everything from credit cards to PayPal payments, often through a single integration. So let's trace a typical transaction. A customer on your website wants to buy something. They enter their payment details on a form, which, crucially, isn't handled by your servers directly, but by your payment processor. The processor then communicates with the banks to verify and complete the charge. Once successful, the processor needs to tell your time system that the payment went through so you can ship the product or provide the service. But how does this telling happen reliably and securely in real time? Especially when it's not a direct, immediate response. This is where asterisk times webhooks asterisk come in. Think of webhooks as automated callbacks or notifications. Instead of your system constantly asking the payment processor, hey, is the payment done yet? Which is inefficient and unreliable. The payment processor proactively tells your system the moment an important event occurs. When a payment is successfully processed, failed, or even refunded, the processor sends an automated HTTP POST request to a specific URL on your server. It's like a restaurant taking your order and promising to call your pager when your food is ready, rather than you repeatedly asking the waiter. Webhooks are essential for event-driven architectures. They ensure your business logic is triggered only when necessary, saving resources and reacting instantly to real-world financial events. For example, when a Stripe payment for an online course is successful, Stripe sends a webhook to your server. Your server receives this webhook, verifies its authenticity, and then automatically grants the customer access to the course content. It's a fundamental part of building fault-tolerant systems, allowing for asynchronous communication without constant polling. But what happens if a webhook gets sent twice due to a network glitch? Or what if your server processes the same webhook event multiple times, leading to duplicate actions like charging a customer twice or shipping two products for a single order? This is a common challenge in distributed systems, and it's where the concept of asterisk times idempotency times asterisk becomes critical. Idempotency means that an operation can be applied multiple times without changing the result beyond the initial application. Think of it like pressing an elevator button. Whether you press it once or 10 times, the elevator will only come once. In payment processing, this is achieved through an idempotency key, often a unique string you send with each request to the payment processor. The processor remembers this key for a certain period. If it receives a request with the same times key again, it knows it's a retry of a previous request and will simply return the original result instead of performing the action again. This protects against accidental duplicate charges or unintended side effects. For example, if your internet connection cuts out right after you've sent a charge request to Stripe, but before you've received their confirmation, you might retry the request. If you use the same idempotency key, Stripe will recognize it as a repeat of the original request and won't process a second charge. Instead, it will just return the result of the first, successful charge. This mechanism ensures consistency and fault tolerance, making the system resilient to network issues and system failures. Beyond webhooks and idempotency, absolute security is paramount. This involves several layers. First, payment processors like Stripe are PCI compliant, meaning they adhere to stringent security standards for handling cardholder data. They use encryption for data in transit and at rest, and tokenization, where sensitive card details are replaced with a unique, non-sensitive token. This means your business never actually stores the full card number, significantly reducing your security risk and compliance burdens. The web dev community strongly advises against doing your own payment processing for this very reason. So let's bring it all together. A customer initiates a payment on your site. The payment details go directly to Stripe or PayPal. They securely process the transactions. Once the payment status changes, a webhook is sent to your server, notifying you of success or failure. If your system was to retry a transaction, the idempotency key ensures that no duplicate actions occur. Meanwhile, all sensitive data is encrypted and tokenized, kept completely separate from your business's systems. This intricate dance ensures that the flow of money is not only seamless, but also incredibly secure and consistent, no matter what happens on the network. These sophisticated mechanisms build trust. They allow businesses to focus on their core product, knowing the complex financial backend is handled with precision. Whether it's enabling multiple payment methods like Stripe and PayPal together, or ensuring every refund request is handled correctly through an API, webhooks and idempotency are the unsung heroes of modern e-commerce. They turn potentially chaotic, unreliable online interactions into a robust, fault-tolerant system that underpins the global digital economy. Thanks for watching. Don't forget to subscribe and share. See you later. Be awesome.
I hope that was insightful. Thank you for watching. Don't forget to like, subscribe, and share. Be awesome.